Hello, my name is George Munn, and this is my project on the synthetic limb. I picked the synovial joint, or also known as the elbow joint. So here is the general makeup of a elbow joint. We have three major bones: humerus, radius, ulna, and we have major ligaments of the radial collateral ligament, ulnar collateral ligament, and the annular collateral ligament. And we have two extensors on either side to keep the bones in place. So our construction process, I went about modeling the humerus bone just by cutting away at MDF and forming, as best as could be done, the shape and connection point of that bone. And then we have the radius and the ulna bone, which kind of fit together as a puzzle piece, the ulna being more of a cup and the radius being a kind of a cup on top, and it fits and can rotate easily on the smooth surface of the humerus. So the bone structure is put together as shown, with the ulna and radius together up to the humerus bone, and then are fitted together with our ligaments. As you can see, the annular ligament wraps around the radius and up the side of the humerus, and we have our ulnar collateral ligament, which wraps around the side. In my joint, the annular ligament and the radial collateral ligament kind of all combine into one using electrical tape. And then to support this, I add additional electrical tape for the flexors and extensors, which are the ligaments and material used to connect to your forearm muscles. So then there's the muscle structure. And as we do the muscle structure, the main focus of this was the bicep muscle to create a contraction and bend the forearm up. As you can see, the bicep muscle is here is using a balloon and the cable sheathing, and a bicep tendon is just attached to the radius bone via a zip tie. Adding more muscle structure to this, once we have the bicep, we need a constrict, contracting force on the other side, in which I use just a balloon under tension to simulate the tricep and also the anterior band, which creates that pulling back motion to keep your arm straight. So here is a general overview of what the final product looks like, and how everything is attached together. And then on to the side, we can see how once the bicep is flexed, the joint is actuated and the humerus kind of will fall into that cup that the ulna provides. Here it is being tested under pressure. As we add air, the bicep contracts and pulls up the forearm, pulling up that ulna bone, just as what happens when our biceps pull up our arms. And here's this one testing it at an angle to show that the ulna provides a mechanical lock for your arm, so your arm cannot bend the wrong way. As we see, bicep pulls up, and it does a very good job at creating